Okay, no, let's riverboat concept. Green color. This river current, velocity of river. So few terms are there. We'll define them. What is VR? Velocity of river with respect to ground. If I write velocity of boat or swimmer, velocity of boat or swimmer, it is. This is velocity of boat with respect to ground. VBR, if I write it, let me use all the symbols possible. Velocity of swimmer with respect to ground. VBR will be velocity of boat with respect to river. VSR will be velocity of swimmer with respect to river. Okay, these are the popular terms which I'll be using. VBR already you know, VAB, VA minus VB bar. So what is it, this entire concept? Velocity of swimmer with respect to river equal to velocity of swimmer minus velocity of river. Oh, this topic is over. No need to bother. That you can straight away go to numerical and start working. Apply relative velocity along X, along Y and work out. This is a core idea, I'm telling this one. Pretty sure. There's no need to even read theory also. Straight away, you know relative velocity, you know kinematics, you know displacement, velocity equal rate of change of displacement. You have to apply. So this is what your entire idea revolves around this. I'll begin like this. Now, what is everything? So there's a bank. There's a bank. And there's another bank. There's a at point A, I'll start it. At t equals 0, the starting point will be this one. So where I'll begin from bank, I have to cross the river. So if the swimmer S, he'll start from one bank. If the boat, he'll start from this particular bank. So bank, what happened? You just show like this. I think I should not use word shore, no. Seashore, it's called as river shore. We should not use river bank. We have to call this. So there's a bank. And what about this? This is opposite bank. Where you start, there'll be a bank. Where you reach the other bank, no, that's called as opposite bank. So there is a point exactly opposite to the starting point, will denote by symbol B. Now how the river flow? The river flow is like this. VR. River current, it is also called as width of the river, W. These are the symbols we'll be using. Now velocity of swimmer with respect to river. He will swim yeah, take like this. What do you mean by velocity of swimmer with respect? So the swimmer weapon will jump into the river, he will dive into the river. When he puts his head into the water, no, he feels he's moving in this direction. He feels he's moving in this direction. So let me take that as theta. He'll make some angle with the reference line AB. So that is VSR. What is this VSR? Velocity of swimmer with respect to river, or velocity of boat with respect to river. What about velocity of swimmer with respect to ground? So here the river current will push him. So the resultant velocity will be somewhere here. This is what? Vs. And now, so you ask the person here, you ask the swimmer, where you are heading. You say that when you're swimming in the river current, you ask him, where you are going to reach. You say, I'll reach D, point D. Then, but what you say? You said, no, you'll reach at C, that one. So what is Vs? Velocity of swimmer with respect to ground. So what is this red color path? Path with respect to bank or ground. What about this? Path of path of what? Path of swimmer here. Path of swimmer or boat with respect to river. So when that swimmer is swimming in the river current, when the swimmer is swimming in the river, he will put his head into the water, no? Then he'll be swimming. Ask him where you are going to, how you are moving. He say, I'm moving along the path area. When he lifts his head and looks at the bank, then he feels that he is moving along AC. VS is velocity of swimmer with respect to ground. VSR is velocity of swimmer with respect to river. I think the sentence itself is there, no? With respect to river. Fine. I think I'll write it. Okay, look at this. So now there's a path with respect to ground. So here, the swimmer will be here. There's only one swimmer. Don't think that there are two swimmers will come. There's only one swimmer in there. Okay, let me give it a red color. It'll be easy for you. So the another person. Look at now. The swimmer, what happened when he puts his head into the river, he feels he's moving along the path area. When he lifts his head and looks at the bank, no, he feels moving along AC. Why that is? Because the river current will push him. The river current will push him. The river current will push him. So what is our question? Shall we take this a drift? What do you mean by drift here? So he was pushed along the river current, no? So that particular quantity will become a drift. Then you'll start at t=0. You will reach here after some time. So what is the time taken to cross the river? We'll find out all the quantities. Now, if it's a boat, let it be instead of swimmer, no, let it be a boat. Tell me like which quantity you can measure. VR, can you measure S? We using fluid mechanics, I can measure VR. Can you measure VSR, VBR, velocity of boat with the river?
నెట్ రావట్లేదు ఇంట్లో ఇప్పుడు ఇంతవరకు వచ్చింది ఇప్పుడు రావట్లేదు.
Nitesh, can you hear me?
Yes, sir.
Okay, no problem.
Yes, sir. No problem, sir. Thank you.
VSR, this VR and VS bar. So now, like VBR. So which quantity are measurable? VR measurable. I'm writing some few very basic terms. VR measurable. VBR. Sir, how you measure VBR? I think nowadays we have got mobiles. A boatman will call boatman. What is the speed of your boat? What is the speed of boat? Please don't need not to suggest anything. Please. Huh? Let me, because when I get a chart, no, I feel some doubt is there. So no need of any suggestion. Nothing. Carefully, happily you listen first. Even if you know some concept, also have patience to listen first. Huh? No need to share. You are not a position to share anything. Try to understand things in different way. Huh? VR is what? Velocity of river measurable. With the help of fluid mechanics equipments, I can measure velocity of river current. Okay, there's no problem with this. What is VBR? Say a boat is moving in a river. I'll call boatman. What is the velocity of your boat? You look at the speedometer of boat, you say there's a speed, and you will tell also the direction, in what way I'm moving. So VBR is measurable. What is VS or what is VB? VS is the velocity of the boat or the swimmer measured from the ground. Can you measure? Not possible, no? For this, what you should do? By being on the bank, you should measure the displacement of swimmer and the time taken. Divided by time taken will give the velocity. Is it possible for you to standing on the bank and measuring the displacement? I think very difficult. No, of course, technology improved. Still, it's very difficult. Exactly, it's very a lot of error will come. So I better let me put we are at 300 years back, so are not measurable. Finish over or 200 years back are not measurable. So therefore, I should not bring any quantity in terms of VB and VS because as it is not measurable. This is one basic rule there in the river boat. The why we are not taking help of VS because the quantity cannot be measured. So no question of expressing any unknown in terms of that one. Getting the basic idea of this. What is the problem? Can you measure the displacement of swimmer being on a bank? You are on a bank here. You are a person. Can you measure displacement who is some half kilometer somewhere from away from you? Can you measure the displacement exactly? Can you? So no, sir. I'll get into the river. VBR boatman. I'll call boatman. The boatman will look at the speedometer. You'll say like, okay, with what speed the boat is moving, and also the direction. Finish or no? Quite simple. Is it okay? VBR, VSR, very, very simple. I'll call swimmer with what speed you are moving. Okay, best than swimmer, no, take help of boat. The speedometer of boat will indicate VBR. And the direction of the boatman will tell what direction is heading in the river current and we'll get VBR. Fine. So what is our discussion now? Our answers, what are answers? How much of time will take to cross the river? Then what is a drift? That X is called like a drift here. So here the quantities here will call as a drift. What do you mean by drift? The displacement of an object under the action of a force is called as a drift. The displacement of an object under influence of a force is called as a drift here. See, I should have used the word displacement, but it's not a displacement. Is it unwanted or wanted? Unwanted, no, the river current will push a forced displacement or displacement under influence of force is called as a drift. The technical meaning of that. And what is W here? We used width of the river. These are the terms which I'm using. So let's come for directly the question like, what is the time taken? So I told you, no, I'm going to take help of this formula. I'm starting it here. VSR equal to VS bar minus VR bar. Let me write this along X along Y. So VSRX equal to relative motion along X-axis. Let me write. What is VSX? Velocity of swimmer with respect to ground along X-axis. What are X and Y-axis? This is X and Y-axis. Similarly, let me first find out the time one. I'll come to this. Drift, displacement of an object under influence of force is called as a drift. What is the force? The river current will push, no? That's why we use word drift. How much of displacement along the bank? What is the drift? How you measure? Displacement along the bank. Okay, got it, no? So let's go for this one. VSRY equal to VSY minus VRY. Will I agree this? The vector form. What is VSRY? Looking at the diagram, VSR cos theta. What is VSY? Velocity of swimmer with respect to ground along y-axis. VRY, how the river is flowing along x-axis. What is VRY? Is zero, no? You can see from the diagram, river is flowing along x-axis. So what is VSY is equal to? VSY equal to VSR cos theta. Okay, no. The time taken, who will determine the time taken to cross the river? Time taken is equal to W by VSY. Who will determine time taken to cross the river? The vertical component of swimmer along, or the y component of swimmer with respect to ground along y-axis. That will determine time taken to cross the river. So what is VSY? W by VSR cos theta. So what is T I should write? Time taken by swimmer to cross, time taken to cross river. Is it okay? I think this is the concept. Don't bother the end formula. This is the concept. Who will determine which component of velocity of swimmer will determine time taken? Vertical component, VSY. I wrote it here. Let's come for that. How much horizontal displacement or displacement along the bank? That will be. Let's apply the same formula along x-axis. I will continue the discussion here. So shall we break up this VSRX? VSRX equal to VSX minus VRX. So this will be VSRX. So these are very important. I'm telling this one. The whole concept is this VSRY equal to this one. I think rest everything you can manage. There's an idea. I just shading them. I'm highlighting that one. Please do concentrate on this. Finish over. The rest of everything you know, uniform velocity motion, all other kinematics, you know it. You can manage. It's very, very pretty easily. You can manage all other things here. The core idea is what you just put effort. Every numerical there's an approach. It's not like something. Not only here, every numerical you can take help of this. Tell me, who will determine the displacement? The x component of velocity of swimmer with respect to ground. Shall I write like this? X equal to Vsx into t. What is the time taken? Time taken to move from A to C is what t, no? In that interval of time, you'll have a horizontal displacement of x. What is Vsx? Substitution of this. Okay, now so we'll substitute value of Vsx. So this will be Vs Rx plus Vrx into t. I'll slide it. I'll slide down. Okay, no. That so what you should call no. What is this? This is a drift. In the end, I'll write it. Now, what is VSRX? VSR sine theta plus VR. Sir, why you are writing VRX equal to VR? That's what no, VRY is 0. How the velocity river is flowing along x-axis. Oh, what is the expression for time? W by VSR cos theta. So what is this x is called as drift. So who will determine the time taken to cross the river? VSY, finish. Who will determine time taken to cross the river? VSX. This is the next, I'll highlight in red color. Every numerical, your approach should be only this one. So how to calculate VSX and VSY depends on the situation. Finish over. There's a theory. So in the books, what happened? They have started not with this idea. So why you find this very difficult? They didn't brought this VSRY, VSY, that one. They're just telling that directly. They're writing this one. T equal to the time taken to cross the river depends on VSR. I think there the trouble will start. So better what happened? We have to begin from here. VSY will determine time taken to cross the river. VSX will determine the drift. Finish out. You need not to bother after this any other thing. Let whatever the type of numerical you can manage. Any doubts you can clarify, because there's a basic idea, because every numerical I'll be taking help of this condition only. All of you okay? The terms. I defined all the terms in some books. They started with VBR. That's why I brought that also. Either boat or swimmer. Let it be same. Any doubt you clarify? So then I'll proceed for the next conditions. Shall I scroll down?
Yes.
Now look at the formula. How is, shall I say, down the stream? Is swimming down the stream. So when you're swimming down the stream, these are the equations. When you're swimming down the stream, these are the equations. So what all we discussed. So what are this? The drift and the time taken to cross the river when you're swimming down the stream. Let me swimming when swimmer swims down the stream. What do you mean by down the stream? Why we should call like that? So look at the VS, how it is. Component of VS is one will be perpendicular to river current, other will be along the river. No, so this particular thing means you will start at a, finally you will reach down the stream. No, where is the point C? You see point C is on the left side of the starting point, right side of the starting point. So therefore I should call down the stream. So there's a condition I brought it. So whenever you swim down the stream, no, so these are the equations you are going to take help of. So let's go for when he swims up the stream. When swimmer swims up the stream, what conditions are there? Okay, next here. When swimmer swims up the stream. What do you mean by up the stream? So there's a river bank.
Sir,
Ah,
sir, when we say down the stream, we meant that velocity of river and velocity of swimmer with respect to ground in x direction are the same
will be directed same. Or say like a,
directed in the positive x-axis. Sir.
here better to say that VSR, component of VSR will be along VR. That's called like a down the stream. Component of VSR will be along VR, then it's called as a down the stream. I'll show that comparison now. So you will start this t equals 0. So where the bank on which you'll start on, let it be that one. So there's a t equal to 0. So now you will swim up the stream. Look at now VSR. If VSR, a component of VSR against VR bar, then it is a up the stream. This is a velocity of river current. Did they? Wait. Now you ask the swimmer, where is heading? You say that I'm heading AB. So like you will say that D. Then the river current will push him. The river current will push him. The river current may push more or less it is. Huh? You may even I can extend this. It may come here also. So this is what you'll get a problems. Let me take this condition. This will be much useful. Okay, now look at, this is Vs. So up the stream, down the stream, what is the best way of like a categorizing? Looking at Vs R bar, not Vs, better. Because you see here also I brought Vs down the stream only. Like this. So what is the best way of categorizing up the stream, down the stream? By looking at VSR bar. So this is the end, you write it. T equals 0 and you will reach here time t. So this is a drift. Okay, let's do again the same method. VSR bar. So we'll determine time taken to cross the river. VSY. So the formula will be VSR what is VSRY? VSR sine theta. What do you mean by VSY? This is unknown thing which we have to find out. VRY will be 0. Why VRY is 0? The river is flowing along x-axis. No? The river is flowing along x-axis. So therefore, VSY equal to VSR sine theta. So we will determine time taken to cross the river. W by VSY. So this is equal to W by VSR sine theta. Let's go for the drift. Let's calculate the drift. So what is the drift is equal to? X is equal to, before that, VSRX equal to VSX minus VRX. So the drift is equal to VSX into time. What is VSX? I think we have to get all these values, no? Okay, anybody? VSRX. VS is velocity of swimmer with respect to ground. VSR is velocity of swimmer with respect to river. I think it's by this time you know relative velocity VAB, VAB bar, VA bar, VA bar are absolute. This is absolute velocity. This is what? Relative velocity, velocity of swimmer with respect to river. VS is velocity of swimmer with respect to ground. VSRX. So this what you write? VSR cost. Why negative sign? You can put convention plus VR equal to this. So the drift is given by this one. So substitute here VR minus VSR cos theta. What is T? So though it's swimming up the stream, still what happen? The drift is, the end point is somewhere on the right side of point A. Yes, it can happen, no? We'll discuss all the cases. So this is about the, when a swimmer swims up the stream. This is a basic condition. This is the two generalized ideas. Swimmer swims up the stream, swimmer swims down the stream. We'll discuss all the cases. There's a initial point. So first you should be familiar with all the terms. What do you mean by VR? What do you mean by VSR? What do you mean by VS? This is absolute velocity or velocity of swimmer. So what you should write? Path with respect to ground or bank, no? And what about this? Path of swimmer with respect to river. You ask swimmer, swimmer say that I'm moving along AC. Then on the bank, what you say that? No, you're moving along AC. Tell me who is right. I think nowadays we have mobile, no? Nowadays we have mobile. So let the swimmer carry a mobile which is waterproof. Okay, we'll call him. I'll call swimmer. My dear, in what direction you are moving? You'll say along AD. What you say? You are moving along AC. Tell me who is right here. Both are right. The frame of reference are different. See, rather than mathematics, I just want you to get that the basic things properly. Finish sure. The rest of everything is it's a formula based. Just you should take help of formula and you can manage. 90% of numericals you can manage with this idea. 10% are just based on some higher mathematics. That where you have to take help of maths here, further integration, that one. Okay, no. So you call swimmer. The swimmer says, "I'm moving along path AD." The person on the bank says, no, you're moving along AC. Tell me who is correct. Both are correct because the frame of reference is different. In the river frame, the swimmer moves along AD. In the bank or ground frame, the swimmer moves along AC. So therefore, path with respect to ground, path with respect to river. Okay, these are
Sir,
the yeah.
sir, if a person from this bank wants to go to a specific point on the other side of the river, then it matters, right, sir? I mean, the path with respect to river, you'll end up with in one point. I mean, the points are different, right? With respect to the frame of reference.
In paper world, come out of paper world. Come out of paper. You mean to say, sir, just before touching the bank, the person, the swimmer, with respect to river, you'll be here. And with respect to ground, you'll be here. The very next moment, what will happen?
No, sir. I meant to say that if he's thinking to go to certain point on the bank, on the other side of the bank, what is the exact path he have to take? I mean, should he take with respect to the ground path, or either in any of the paths will end up in the same point?
You have to come out of the book world. That's what I'm saying here. See, you will jump into the river. VSR bar will be there. That's what finish over. When you're standing on the bank, you look at sea. I to go at sea. To go at sea, suppose VSR is like this, no? What you are saying is that one. He has to move from A to C. If he keeps his VSR like this, what is the problem? VR will come and it will be pushed. He will reach somewhere here, no? To reach C, what pen? He should swim with respect to river along AD only. The river current will push. So he'll reach now C. If it swims, if VSR is along AC, then what is the problem? The VR will come and push and VS will come like this. You reach E, no? Getting this? You have to analyze here. Huh? You have to draw a diagram. We have a habit of looking at things and want everything. Huh? We don't want to draw a rough diagram like. There's a, maybe in schools we were not taught even there's a very general almost in education system in this developing countries or what you can call third world countries, no, it's all about gathering information, not about analyzing. Students were never taught to draw rough diagrams because when I look at your notes, no, they're very neat, then you'll become accountant, you'll not become engineer. The classroom notes itself, what pen should a lot of scribbling should be there, no? Oh, sir thought like this. If VS are like this, what will happen? So this analysis is what will be missing. Even the working book also, no diagrams will be there. Now, okay, due to lockdown, I'm unable to see. But past several years now, I'm telling you very clearly, students' notes, even their working book, are so neat that not possible. Huh? Engineer notebook will not be like that. Definitely, I can say. There, the real problem arises. Students don't want to analyze it. Question immediately answered. So there, what happened? You are not learning. Actually, you are ending up with answer. Okay, what is a for a given question when you end up answer open, you have actually completed only 10%. There's a major problem what we are facing. That's why in the research, why we are so backward, there's a reason. Because we know only one point of view. Yesterday I gave assignment. I know they are very time consuming, that one. So at least what happened, you should you should have replied me on Saturday, sir, will you discuss? But most of you are saying that, sir, will you discuss tomorrow? No. So you're bothered more about what now? Gathering answers for a question rather than learning. It's very easy for me. Okay, what is there? I'll display question. Okay, there's a method, there's answer, I'll show it. But finally, what you got? Nothing, no? You're not didn't gain anything. So today is what, Tuesday, Wednesday, Thursday, Friday. On Saturday, you could have said to me, sir, like, can you at least discuss few questions? We tried a lot. So almost I got in WhatsApp almost around 80% of students. I just gave intentionally. Let's see what is your approach, how your approach for science. That's what I know. 80% of students have asked me to, sir, tomorrow you discuss assignment. So here the student, the kid is more bothered about gathering answers only rather than learning. See, you learn only when you try the question. I'm not bothered answer. See, that's why I didn't give answer. I didn't give key. Why I didn't give key? Because I'm not bothered about like where you end up. I just bothered about you whether you tried or not. If I give key no, then what, when you will become one direction. So to get that answer, you are thinking. Okay, today evening I'll upload, but I suggest you, like, you should put effort. Nothing wrong. See, sir, you gave all, none of the questions I solved. No problem. I see. Did I ask you that how many questions? So if you don't solve, I'll not permit to the class. I'll block in the Zoom. I'll remove you from this group. Nothing sort of that one. No? See, when I give assignment, even if you don't solve, but you really struggled 2-3 days and put effort, drew many diagrams, analyzed everything, it's good, no problem. So science needs effort. Huh? You cannot hear me. Huh? All of you able to hear me?
Yes, sir.
Yes, sir.
Check your once like a mute and unmute, you do it, and refresh, you can do it in your mobile or laptop. Huh? Okay, there's a condition. Huh? Let's go for conclusion part. Okay, now let's. I'm more interested in specific case, like, so I'm in Ari. I want to cross the river in minimum time. I'm not bothered where I'll reach. So what is the thing? Time taken to cross the river in shortest time. This is what I'm putting. I want to cross the river in shortest time. Means like I'm not bothered where I'll reach. Tell me how I should swim. This is what the practical necessity will come. So what is the next thing is time taken. Time taken to cross river in shortest time. Okay, let's come for here. What you can, we have a time here, no? I'm asking all of you to look at this equation. We have a time here. Look at this. When this T will be minimum, W and VSR you can't change. W, width of river, can you change? Width of river you can't change, no? And VSR, what is what? Velocity of boat with respect, that also fixed value. The boatman, he will row boat with 40 or 50 kilometer per hour. So W and VS are fixed. So can you vary theta? Yes. By varying theta, can I control time taken to cross the river? Yes. So, but I want to cross the river in shortest time. So T should be minimum. When T will be minimum? When theta 90. I'm asking you to all of you to look at that yellow color highlighted one. It's over. Straight away I'm bringing. So what shall I do now? So when it swims, how it should swim? It should swim normal to river current, not up the stream, down the stream. The swimmer should swim normal to river current. So here, there's a bank. So if it swims up the stream, sorry, if it swims normal to river current, the river current will push him. So the river current will push him. Then this will be Vs. So what is the condition for him? He should cross the river in shortest time. That's all. He's not bothered like a this one. Where he will reach? He will reach here. So this is a start point, and this is the end point. So he will start at t equals 0. He will have some drift. This is the thing. Okay, look at this diagram. This is very important. So now, why you are showing specifically? So what is the basic thing? Time is equal to W by. I think I have to go back to, sir, why you are writing directly the answer. So when that value of t will be, when t will be minimum, when theta equal to 90 degree, no, I'm directly taking help of this. So shall I write directly the answer? T equal to W by VSR. When it seems normal to river current. Okay, that one. Yeah. So that one. So what to do with the drift? You'll undergo some drift, no? The river will push him. So what about the expression for drift? The drift is given by, there's a shortest time. T minimum, better you write. This will be. So what about the drift? The value of drift is x is equal to, shall I write directly only VR into T? VR W by VSR. There is some angle called alpha. So what is tan alpha? Tan alpha, you can write it as VR by VSR or X by W. I think going to help you a lot in numericals. So how to calculate the drift, either by this mathematics or through this particular triangle. What is this you should call? Path of swimmer with respect to river. Here path with respect to bank or with respect to ground. So to cross the river in shortest time, yes, I should use this method. Next, the shortest path to cross the river. Next condition I'm putting, shortest path. What do you mean by shortest path? The drift should be 0. These are very important thing. These are the formulas where they are applicable for this situation only. What I discussed earlier, no, the first two cases, they are generalized, every numerical. These are the two conditions. These are the two situations. These are not like universal. To cross the river is shortest path. If you want to minimize the drift, if you want to make drift to 0, then you have to use this formula. When it's crossing the river, when it's crossing the river normally, then you have to use this formula. But what I discussed, the first and second case, no, they are universal. Applicable in almost every numerical, you can have that condition. No, what do you mean by, I'll go back to the basic diagram. Shortest path. When I can have shortest path? I think I'll, okay, look at this. I'll want you to see all at a time. I think you are able to see shortest path. What do you mean by that? The drift should be 0. So what I should do adjustment here? The x should be 0, no, here. Sir, why don't you go for the first diagram? Here drift, is it possible to become 0? We do have many situations you have to compare. Where do come for here? Is it drift possible to be 0? The very first diagram I'm bringing. You must bring your common sense. Under any circumstance, drift will be 0. The drift will be non-zero, no? Here, when it swims down the stream. So I should not bother about this condition, no? To make drift 0. So whose help I should take? Just be online. Some UK sir is calling. Answer here. Those yesterday I just requesting you some any one of you like around 3 students, no, you can send me your ePregna username and ID. ePregna. Shall I randomly select names from the chat? I don't think I'll pause record the discussion. So this is, I think, to minimize drift. I think if I swim down the stream, no way, no, this condition will not help. So to minimize drift or shortest path, what do you mean by shortest path? The drift should be 0. Tell me, like, shall I swim up the stream only? Will I agree? Can I make x 0 here? If I make x 0, what will happen here? Yes, x can be 0 here. Then look at that one. VR equal to VSR cos theta. Yes, I got a condition. So minimize shortest path means the drift must be 0. So directly I'll write it here now. Oh, yeah, come for the shortest path means the drift should be 0. How he should swim? He should swim up the stream only. Oh. Okay, let's come for this one. Cursor problem. Yeah. Okay, now let's say there's another bank. Shortest path. What do you mean by shortest path? You will start at t equals 0, you'll start at A. He has to reach exactly a point on opposite bank. He should reach here. This should be the end point. So there's a river current. River current. And there's the width of the river. Velocity of swimmer should be directed like this. Yes, the same diagram I'm continuing. And this will be velocity of river. So how VS bar should be? VS bar should be perpendicular to this. So I'll take the same angles what we continued. No, so this was the theta we took. Let me take same theta. So this is called like a shortest path. Means you should exactly reach a point opposite on other bank. That's the meaning of shortest path here. Now time taken to cross the river in shortest path. Time how to calculate? We will determine time taken. So here, what is the basic condition? What is the expression for drift? Drift will be 0, no? So from that, shall we write like this? I want you to, what should be 0? VSX must be 0, no? Will I agree this? So I'll start like this here. VSRX is equal to VSX minus VRX. Will I agree this? VSRX, velocity of swimmer with respect to river. So it is what direction? Minus VSR cos theta. This should be 0, VRX. So VSR cos theta should be equal to VR. So what is cos theta? VR by VSR. What was our question? Time taken to cross the river. W by, we'll determine time taken to cross the river, VSY. W by VSR sine theta. Sine theta, what you can write? Root of 1 minus cos square theta. Substituting this, what is cos theta from here? VR square by VSR square. So the final answer will be W by, okay, fine. There's a time taken to cross the river in shortest path. I'll write nearby only. This is the answer. Getting the idea? This will be. So here, what is the path? There's a path with respect to ground. And what about this? There's a with respect to river. This is what actually you have to process. You can ask question, sir, why VSX is 0? Because drift is 0, no? Drift is 0. And why sir, W by VSY? How VSY equal to VSR sin theta? VRY is 0. So go back to again the same basic way of. So what is this? This will be VSR sin theta. That's why the VSR sin, VSY has become VSR sin theta. These are some background. So the what I earlier discussed, no, that VSR x equal to that one, that you should not forget. So this is a basic idea of the shortest path here. So two things are there in front of you. Shortest path, div 0. For shortest path, you have to swim up the stream to cross the river in, so like a least time, in a shorter, or so like in a minimum time, you have to swim normal to river current. And whenever I say you should swim, means I'm saying VSR only, not VSR, not VS bar. VSR bar only, what happened can be measured, no? So you should swim normal to river current, means it's VSR only. Because this quantity cannot be measured, so we are not bothered to even indicate also. So, and even in questions also, nobody will ask you to determine them. You can't hear me. Just can you hear me now?
Sir, I changed to another device, sir. Now I'm able to.
Can you hear me?
Yes, sir.
Okay, I'll continue now. Is that okay now? So these are the time they count. So now I'll put one. Sir, if you sims up the stream, then where is the end point? End point is there, no? So can it happen? One more situation like this, where it sims up the stream and the displacement will be on towards left. Let me give last one more. So this will help you a lot in numericals. So it will start from here. This is a start point. T equals 0, it will start it here. The river current is flowing like this. VR. Velocity of swimmer with respect to river. The river current will push him. And the VSR bar is like this. I think this is a totally different situation, no? So you look at the path I'm showing, no? Where is added? This is A, this is B, This is C, this is the end point. Okay, fine. So now we have conditions like this. Yeah. Now you, what is this path I should call? Path with respect to river. What about this path with respect to ground? And it will reach in a time t. Let me write it here. Okay, now let's write expression for crossing the river. Let this be theta. So directly shall I put W by VSR sine theta? What about the drift? X equal to VSR cos theta both will be negative. Directly I'm writing. You must think on this. Negative sign, what do you mean by negative sign? Towards left. The drift will be towards left here. The swimmer, what happens, he says, I'm adding to point B, but he will end up at point C. So now look at this one. Is he swimming up the stream or down the stream? The swimmer swims up the stream. So where he is reaching? On the left side of the point B. So when he swims up the stream, what are the possibilities? He may reach, the drift will be negative and the drift will be 0, or the drift will be positive also. Able to make it out? I think we have the first few cases, no? The second case, though he swims up the stream, the drift was positive. So when he swims up the stream, what will happen to drift? Drift can be positive, negative, or 0. Is that okay? So there's one basic condition here, that one. So here the drift is towards left. So that's why the negative sign is brought here. How do I wrote this? You have to go back to your basic mathematics of relative velocity again. Okay, this is overall the core ad. So in a nutshell, I just wanted to, VSY will determine time, VSX will determine drift, finish all. And every problem, it will be like this. VSR bar is equal to VS bar minus VR bar. So this is the core idea. So don't fight with the formulas. So every particular formula which you are not understanding, start from here. Resolve this along X, along Y, apply this along X, along Y, and that. And we'll determine the drift, X component of velocity of swimmer with respect to ground. We'll determine time taken to cross the river, Y component of velocity of swimmer with respect to ground. Okay, so in books, what happened? It has become some sort of random.
So shouldn't that be plus VR? I mean minus VSR cos theta plus.
Instead of fighting with this, better go back and apply the formula rather than fighting with this. Go back to the formula. The best thing is go back to formula. So what that formula says, VSRX equal to VSX minus VRSX. No? So the diff depends on what? Let me substitute all this. What is the direction of? So this will be VSR cos theta equal to. So VRX, this will be towards right, no? This was a negative. If you take towards right, positive. So VSR bar was towards left, negative. And this is what, like, you say VR. Okay, no, I'll put it VR minus VSR cos theta. Okay, I think I should change the sign. Huh?
Yes, sir.
Plus it will be, this will be minus. So this will be negative. Okay, no. I'll write it. Here it will come. So here definitely VSR cos theta will become greater than VR and X will become negative. So you leave it to the values. It will determine that particular thing. The same earlier method. So VSR cos theta is towards left, no? So take help of sign. So this should be positive. Is it okay? No, I just took help of the basic formulas. You need not to make a guess of anything. Now in your numerical, if VR greater than VSR, tell me where the endpoint will be on the right side. If VR less than VSR cos theta, then where the endpoint will be on the left side of this one. X will become negative. The X is positive, negative will determine this particular bracket term. Here I assume that VSR cos theta greater than VR. So therefore the endpoint has come on the left side. The diff will be positive, negative based on this particular bracket. So the method will be same, no? You can see here, any situation. So when you're getting a question, no, you have to be very careful. If it seems up the stream, so VSR you have to assume against VR bar. So the condition. If it seems down the stream, the very first diagram, if it seems normal to river current, VSR bar will be perpendicular to VR. So if it seems up the stream, component of VS1, horizontal component of VSR should be against VR bar. Okay. If it seems normal to river current, VSR bar should be perpendicular to VR. If it seems down the stream, the component of horizontal component of VSR should be along VR bar. That's the idea. So in the questions, diagram will not be there. You will just put a statement. If it seems up the stream at an angle theta with the bank. So you should assume this diagram. It seems down the stream with an angle theta with perpendicular with AB. And these are the ways of giving that one. So you do make observation of those sentences. Okay, all of you. Today you learned about the rain umbrella, some numericals, and the river boat theoretical concept. Tomorrow, based on this, we'll discuss the numericals, all the application numericals, everything. Okay, fine. Meanwhile, you can try some basic problems related to this. You can work out some few basic problems. Okay, all of you. I'll continue class tomorrow.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, please send the answers of the key.
Yes,
of the
yes.
assignments.
Everything will be uploaded. I'll send the answers also today in assignment.
Thank you,
Okay, sir. Thank you, sir.
Okay, all of you. Bye. See you tomorrow. Take care.
Bye, sir.
Thank you, sir.